For the last 200 years, some of the mathematical ideas have evolved in the machine learning and artificial intelligence area. Some of the main ideas, which I think are critical pieces of understanding, right, or the building blocks of AI. We don't even use a fraction of our brain, not even a minuscule fraction of our brain.
Good morning and good afternoon, everyone. For those who are not yet aware of myself, Sarita, your moderator for the day. Been in the industry for over 18 years now. Primary programmer, primary technology postgraduate from computer science, and then I started my career for a couple of years. Teacher in one of the school, teaching students. Then I started my career a couple of the big CROs in the industry. Started my career as a programmer and then led global teams. Did a lot of work in the industry, worked for multiple sponsors, process improvements, all of it. Other than the work, I'm also a very active volunteer on some of the industry forums like SCDM, Fuse, and then another which is very close to my heart is Healthcare Business Women's Association to empower women, bring in parity in the industry, in the organizations, and bring in more leaders. That's little about me. Now, the very, very highly respected speaker whom we have is Surya Putchala. He is Chief and Generative AI Specialist at InvestMates. Thank you so much, Surya, for joining us and accepting our request to be on speaker today. To give a quick intro of Surya before we delve into the discussion, Surya is very seasoned AI leader with over 33 years of experience in technology, strategy, data science, and AI innovation. As a chief AI strategy and generative AI specialist at InvestMates, he drives transformative AI initiatives and advises organizations on leveraging Gen AI and large language models for real business impact. Surya has co-founded multiple AI-focused ventures, including Jetamind Labs and Capius Technologies, contributing to over $20 million in successful mergers and acquisitions. That's very interesting, and it's not that we have little more. So his previous roles include some of the senior leadership positions at HCL Tech and Accenture, where he led large-scale analytics and BI transformations for global enterprises. He's an IIT Kharagpur alumnus. He holds a MTech from IIT Kharagpur and BTech from Sri Venkateshwara University. And then reflecting his strong academic foundation in technology, he is known for combining deep technical expertise with a sharp strategic mindset. He has delivered over 50 AI proof of concepts across industries like finance, healthcare, and retail, and he has mentored 300 plus professionals and helped shape the AI journey for 6 startup organizations. That's a lot. And he's very recognized thought leader and LinkedIn top voice in AI. Surya regularly speaks at leading industry forums and contributes to advancing AI literacy through mentoring, publishing, and education-focused initiatives. That is one of the reasons why we have Surya here in one of our AI education learning labs. With that, thank you so much for accepting our request and joining us and coming up with a very interesting topic, Surya. I'm welcoming you and thank you everyone for joining us. All over to you, Surya. Thank you so much.
Thank you very much, Sarita. That was very kind of you to introduce me. I am very glad to be here. This topic is kind of new to me, and I, put together a few slides to make it little interactive, just to share with you all my understanding of how mathematical ideas, some of the mathematical ideas have evolved in the machine learning and artificial intelligence area for the last 200 years, is to basically understand, how do we process data? How do we understand things? How do we conceptualize things, right? And these are the aspects, what we call philosophical aspects. And it is called epistemology, okay, in philosophy. Or, do we understand by abstraction? what is our way of learning as human beings, right? That is one aspect. And then machines, what are they capable of doing it? Do they really abstract anything? How do we teach them to basically learn and also understand how do they learn? How do we teach them to learn? What do they mean by learning? So let us dwell just a little bit on that aspect. Some of the main ideas which I think are critical pieces of understanding, right? Or the building blocks of AI. You have a picture here. One object is in green, other is in orange. So what is it? You got it, right? I mean, why am I asking such a simple question? Right? We can tell very easily what it is, right? One is an apple, another is an orange. Okay, come on. But did you notice the color of the apple? How do you remember apple to be, right? So just keep that in mind. Then move on to the next slide. Okay, think about this. If I ask you a question, are all these apples? And you will definitively say that all these are apples. Then I will ask, how did you say? Here, the first question, if you had a conception, apples are indeed the type of orange, the apples that we see in India are Shimla apples, right? The Simla apples predominantly are in pinkish, reddish colors. But whereas here, you have a lot of different subtleties in shape and color and a golden delicious apple, the one which is here. Right. So, what's happening in your mind, right? How did you train it? Did you consciously learn the apples are going to be even this also? Or are you using, even if color of apple, you have still used some of the attributes of apples and applied to an object that you are seeing, right? If that is how you're learning, and then the next slide will boggle you, right? In this case, in the fourth case, where the golden delicious is in golden color, in this slide, when you see a golden orangish fruit, if I ask you what this fruit is, what is it? You'll say it's a berry, right? What type of berry do you see in India? They are green in color, right? Here, this darn thing is neither green in color or green, or it looks like apple, but you can still differentiate. My God, what is the beauty, right? How did you think about it? And then the next fruit, what is it? It is similar, okay? Just forget the background image where the fruit is cut. For example, the fruit is given as it is without the cut fruit at the background. What would you say it is? You'll say it is honey melon or musk melon or some melon it is, right? So, how are you distinguishing? I have tried to confuse you with color. I have tried to confuse you with the shape. Still, I could not fool you. Did I fool you? I did not fool you. Oh my goodness. Are human minds brilliant? Yeah, we don't recognize we are brilliant, but we are brilliant, right? We are brilliant anyway. This is just a message for people here who are listening. It is often said that we use about 5% of our brain. Okay. I think Einstein or somebody has said that. But I don't believe we use even 5% of our brain. We don't even use a fraction of our brain, not even a minuscule fraction of our brain. Okay. In active thinking, I mean to say, right? When we actively think, if you go to a computer and then when you see performance characteristics of the CPU, and when you give a program to run, okay, it runs at 80% CPU utilization or whatever, and rest of the time, only when it is running, it runs at that capacity. So our brain also, it is a whole lot of a thing. And then if you have 24 hours a day, 8 hours of a day, it is not actively thinking. It is processing at the background, right? What we call subconscious mind. And then, for example, right this minute, I'm making you think. You're doing multiple things at this point of time. You're listening to what I'm saying. You're seeing what I'm showing. And there is another process. You're also following and processing your own understanding. You're trying to understand, you're trying to guess what I'm going to say. You're going to predict how it is going to shape up. There are a lot of questions that are in your mind. That means from a very, very inactive state, you have moved it to an activation state. And then you're not actively solving any problem. It is kind of watching a movie, right? It is very passive at this point of time. That means the capability you have is just under you. I mean, it is utilized, but if you really use it to actively think at least 5% of a day, I think you will become an Einstein. And it is not easy to do, right? If it is easy to do, all of us would have become Einsteins, right? It requires dedication, effort, commitment, and then, discipline and persistence. Right. So it is not as easy as we think, but to understand these thinking patterns are very important, right? And it's part of philosophy. Okay, let's move on to the next slide. I'm showing earlier we have seen inputs of all apples, and now I show a plum, right? And I ask you, why is it not an apple, right? And I have shown you a cherry, and I'm asking you, why is it not a apple, right? Okay, so if you go to your conceptualization or your abstraction of apple, I would say apple is typically red in color and heart shaped. The shape is a heart. So both these fruits also fit that description, but it is not, and you are able to figure it out. Wow, right? I think that should start to boggle your mind. Okay, now let me stop just a little bit, and then I've shown you all confusing inputs for an apple and asked you some questions. If you want to use a likewise comparison, right? Basically, you have a conceptualization of a object, right? And then I asked you two questions. One is, what is similar to what you have as an apple? And you are doing comparison without your knowledge, right? It is happening. That is what is subconscious learning, right? One is active learning, and there is, you have already learned something, and then you are applying it, right? Learning is difficult, right? When you want to learn the numbers, just imagine how many iterations your teachers will have to make you go through, the type of practice you have done in your class 1, class 2, class 3. And then if they ask you to recite the numbers or the tables, how easy for you? That means some of those which are critical, the foundations, you have to keep learning them very, very hard and understand to the core, right? Deep down. And then they are committed to something called your heart, right? That's how your neurons are hardwired. And then the next step is just applying the same thing, right? That is our mental model of understanding and learning, right? So here, what did we evaluate? Just think about it, and if you can chat just a little bit in the window, I'll understand. Okay, so let me jump to the next slide and solve the problem for you.
There were few responses, Surya.
Okay.
So it mentioned that shape is one of the attributes. That's how we learn, right? Since our child age, young age.
So there are two aspects that are happening. Okay. One is we have an abstraction, right? It is a template, like in computer terms, in object-oriented terms, right? We call it a class, right? Class is not an object, right? Class is an abstraction of what the object could be. Actual object is different, right? Only when we instantiate that class, it becomes an object, correct? Mm-hmm. And then we are all human beings, right? And everyone looks different, completely different, right? Yet we are all the same, right? Oh my God, how do we know we are not chimpanzees or monkeys? We can also find out which region they are coming from, right? Oh, this guy has come from Tamil Nadu. This guy has come from Kerala, Karnataka, whatever, right? How can we say it in an instant? Or when somebody, if you have met someone, he will tell you, hey, are you from Punjab, right? Or if I see a Sikh from Punjab, I'll say, hey, he wears a turban. And then I can very easily say, hey, this guy is a Punjabi, right? A Sikh Punjabi. So, and when I see a Tamilian, I can still say a Tamilian. So the processes that we use are different in both these two situations. One is turban is a differentiating factor. Given all the rest of them are the same, right? This is what distinguishes one from the other. That is the type of process I'm using. Whereas when you see a Tamilian, right, it gets much more subtler, right? You are using a lot more similarity of a specific section of the people who represents that class. And then you find a similarity of the object with that class and then say, hey, this guy is this. So you're doing a comparison within your mind, which you think happens in a flash, but it is not happening in the flash, right? It is the mental model that you have, right? It is a mental model. And then we are applying that model to what we see in the real life, right? And then we come up with an answer. That's how the human mind works, okay? So here, what we have, we think, right? If we have to write a program, which is the next slide, we would consider weight because even without showing you, go to this, without showing the size, we can only know the color, we know the shape, we don't know the size or texture or whatever, weight. Right? But if we have weight, color, shape has many ways of representing in numbers, right? Which is when we represent any feature in numbers, we are using something called quantification, right? We are quantifying something. Unless we quantify, the computers don't work, okay? Computers work with computation, right? Basically. And then the texture, right? I mean, here we can see there is a texture by means of just the image that is happening, right? You are not touching it. Human beings are not touching it. Computers are not touching it. But by looking at it, we decipher a lot of properties about it, unknowingly, very unknowingly. So if you have to write a computer program, okay, write a program which will differentiate apple from orange, okay? And then I will give all these cases that you will have to write, okay? So how complicated will this program become? Extremely complicated, right? Unless there is some way of, let us say, we use a graphical method. Okay, let us talk about this method, right? And then say, we have considered two quantification objects. One is ripeness, and there is number of seeds. Right. And then we map it out on a graph and then say, these are all oranges and apples, all of them combined together, right? Different fruits that I have shown you. Okay. It's just representational. I haven't put the colors correctly. And now I ask you to separate them out. Oh, these are oranges, these are apples, these are, plums, etc. And then when you look at it, you can't really separate them out, right? Even when you do this. That means we'll have to come to the next slide, right? Let us say the properties that we have used here in the ripeness and number of seeds, right? Those are the two parameters. We can use multiple parameters. When you use multiple parameters, it becomes multiple dimensions. That's all it is. Instead of a line separating them, you will have a plane separating them. And the more dimensions they are, n minus 1 will be your the plane or hyperplane that you will have in a three-dimensional space or n-dimensional space. Okay, so it becomes higher order mathematics. We will not be able to see them. Those dimensions we will not be able to see. Here, when you say weight and color, right? And then I have, separated these things out very clearly. And all I have to do is to basically put the lines of separation, right? Like this, and then write conditionals. Right? Because we know where the intersections are happening. And then we can say, this is a linear equation with a bound here and bound here. This line, which is bound here, I can teach the machine to become a rule rather than writing if then else, and then convert this mathematical equation and bind that mathematical equation, right? And then you will be able to separate it out. Got it? That is a simple idea. That is, we call it classification, but that is how we separate. That is the separability, right? There are two things. How do you distinguish? How do you understand similar ones? In machine learning terms, how do you separate things? It's called discriminative, which is called classification, right? And then the similar ones, which are similar based on certain properties. What are they? That is called clustering, right? So these are the methods. They haven't come from anywhere. It comes from, how do we try to solve the problems? Next, let us see what is this object here, this object here, this object here, and this object here. What do we see here? Just respond very quickly in your chat. Oh, it is very easy. All are people, right? So anybody said anything else? Right? A group of people, community and all that. So what are the type of pictures, right? One are celebrities. You see, this Leonardo DiCaprio, Jennifer Lopez, all those guys, right? And then here, unknown guys. These guys are known, so these are celebrities. Here, some random people, and here some random graph, and here you have sellouts. No matter how I try to confuse you, you won't get confused. Okay. Now do this in an instant. Okay. You can do this, right? I mean, you can do this. You have to add 2 plus 1 plus 1 plus 3 plus 8 plus 7 plus 8 plus 10 and carry forward 1. Yeah, you do it for 100 hours. Okay. So it takes hell a lot of time to do this, right? So here, what I would like to tell you is the power of computing and power of abstraction and thinking. So naturally, we humans are gifted with cognitive abilities, right? Let me briefly show you what those abilities are, right? And how do we perceive things? What are all some aspects of perception that we have, right? So our 5 senses are perception, right? So, how do we convert each of the sense to a computing paradigm is what machine learning and artificial intelligence is all about, right? So in the latest LLMs, I would like people to go and then check out deeplearning.ai. And then there are OpenAI models, ChatGPT 4.0, right? Which has a reasoning engine, right? Reasoning and problem solving engine. Okay. You go there and give them a puzzle and ask it to solve it. Okay. It says thinking. And then it gives you all the steps, the reasoning steps. Otherwise, you give them, you cut and paste a puzzle from elsewhere, right? And then paste it in that engine as a prompt and then see and ask it how you solved it. Okay. Give me all the steps how you solved it. Okay. It gives you all the steps. Or you give a normal problem from any of your engineering class, right? Fluid dynamics, mechanics, whatever it is, right? You give it and then ask it for reasoning and solving the problem. It will be very interesting exercise that you can do. It will do reasoning and problem solving. That's fantastic. And at this point of time, I am communicating. That means I can talk, I can understand, I can respond, all this. And then as I keep doing this, multiple points in the brain, areas of the brain gets activated, right? So that's where the neural network seems to be working. Okay. What is artificial? How do I make AI a reality, right? What is the knowledge that we will have to, number one, abstract and then represent and then teach it to work like how we do. So these are the 3 things that we will have to teach computers to basically learn like human beings, right? Because our capability is all the cognitive capabilities that I have discussed. Their capability, as I've shown you earlier, is just computing. That means we have to enable, just like, for example, just like we have given a class object, right? A class is class and object we spoke about, right? Just like what a class is doing, that's an abstraction. That's a representation of an object. And then when you instantiate it, that means when you provide data, it becomes an object, right? When you have a series of objects, then you will be able to compare or cluster, right? Either you can discriminate or you can understand what is similar to each other, right? So all this is part of the computing paradigm. We have been building all this from a long time ago, right? It did not come in like a flash or a magic, right? We've been doing it. And then artificial intelligence draws its power from multiple disciplines, right? And it is, when I say science and scientific method, right? It is a empirical method. Science is very, very empirical. It doesn't have emotions, right? It just goes by data and evidence and then says, hey, one way or the other. And computers also do the same thing. That is why we call computers, they are not empathic. They don't have human qualities. How can they have human qualities, right? They don't have consciousness. They have only memory, right? And memory can have a lot of concepts and then reasoning and all that, right? Rules and how we represent all the rules, etc. All that comes into how we represent knowledge, right? It's called knowledge representation. In data mining, we used to call it, knowledge extraction, knowledge mining, knowledge representation, right? So these are all the areas where we started building for the last 200, 300 years, right? For example, Bayesian statistics. Bernoulli has been doing this for 200, 300 years ago, right? All those come into play. And then mathematics plays a huge role, right? I will briefly tell you what the trick of mathematics is, right? And then philosophy. Philosophy gives us a way to understand how we learn, right? It gives the constructs of learning constructs, right? Philosophy is not Vedanta, right? Not only Vedanta, right? Don't get me otherwise. Philosophy is all this thing. So we are talking about various methods of thinking, various patterns of thinking, right? That is what we call philosophy. That's the branch of knowledge, right? And then what are some of the tools and techniques, right? How do we enforce certain things? How do we understand the causal relationships between various concepts, various events and causes and cause and effect, right? How do we understand cause and effect? What is stimulus and response, right? What are the relationships? How do events impact certain outcomes, right? Those are the inferences that we have to derive, because we have to not only deal with the similarities, we have to deal with how events interact with each other. That is what we call dynamics. How do we understand dynamics, right? And then there is rational course of action. That is quantification. How do we represent various features that we have? And then, of course, human behavior, right? So when you give something to the chat, earlier 3-4 years ago, when you are interacting with the chat, how are the chats? The initial brush with chats that we had, or it was like a IVR, right? It gives press 1 for English, 2 for Hindi, and all that, right? How was that when compared to what is happening now, right? I am Sarita, I'm here to help you. What is your issue? And you solve it immediately, right? That's how the chats have evolved. That means there is more humanness into what we are doing, okay? And what are the computational methods? It's very important, right? We are dealing with so much of data. We need a lot of visualization, and then we need advanced methods which will build on what we already know. That is AI and machine learning, right? And quickly going back to traditional programming, right? We all know a program gets data. What is your input? And then, the output it gives for a specific purpose. They are all very, very narrow. They are computational in its approach, right? You give an input, it gives an output. It doesn't do one thing. The paradigm is you ask a question, it gives an answer, right? Which is different than you give an input, it gives an output. Okay. That is one is a computational paradigm, other is a human paradigm. Okay. So we have to achieve something in between. That is, you have an output. That means you know what your target variable is. And then you have the data, right? And then you learn all of them, all from the data, and then it gives a program or an equation or set of rules, right? And then that is what we call learning, okay? And that learning is persistent in a model, right? As a model, and then when we give an input, it gives an answer, right? The model is persistent. That means it is memorized. It is memorized from various examples that are given to it, right? So machine learning, let me simplify this for you. Machine learning is nothing but learning a specific equation, period, the end, right? And here we will see in the next slide. And now I'll give you this simple problem. Here we see, some of the great players, which I randomly took, right? So if I give you this, and I ask you very quickly, hey, whom do you think is the greatest? You come with your answers and you give me the answer. What is your answer? Do I have some chat scrolling? This is answer should be easy. Somebody can say Dhoni, somebody can say Shane Warne, Brian Lara, you name it, right? But how did you arrive at that answer? Yeah. How can you justify your answer? Yeah, right. Right, absolutely. Bharat has come out. What is it? What is this combination of multiple parameters and the context? It's very important. right? What are the parameters you're considering, and what is the context you are considering, right? That's the what is your point of reference that you are considering. That becomes a model, right? That becomes a model. For example, I'll just go here. Okay. So when I ask you who is the MVP, somebody will say Sai Sudarshan, right? And here, mine this IPL guy's numbers say, wait a second. Okay, who will think Sunil Narayan, yaar? Okay, we are Indians. We like only Indians. Shubman Gill. So what's happening here? Your representation is not entirely empirical. Your model has a lot of bias in it, right? Or you can tweak the model. How do you calculate impact? So that is a formula. Impact per match is a formula. Anything to decide any of these things are a formula, right? That formula is unique to you. Okay, what you will have to remember. Okay, so that is what the model is about. The model is the set of equations you have set for yourself, right? So what does a model contain? A model contains the representation of the features of the world, the context of the world. You feed in the data, and then you get the object, right? Just as in on the object oriented programming. And then you use the models of computing and the logic. You can write a program to say differentiate, or either you do classification or you do clustering. Okay. Model also can be a conceptual model, right? You lay out, for example, two different type of things, right? One is you suspect that indeed this is the type of model I want to use, right? In the ancient times, we have used geocentric theory, right? Plato and Ptolemy and all these guys. And now Copernicus, Kepler, these guys, Galileo, they have used heliocentric theory, and then they justified. When you see the data coming in, the moments of the moon, the earth, sun, and with respect to stars, it doesn't completely fit into the equations that are sent for geocentric. So you reject it. That means when you calculate in the IPL, you have one model which you have translated from the data which is coming from IPL, their statistics, and then, one or the other will fit in, or it may not fit in, right? When it fits in, you have a winning team. If it doesn't fit, you lose. Just like what has happened to SRH, right? Their model, for example, their strategy is to get all hot candidates from the market by paying the most, cash. Okay, that failed. That model failed. How do I achieve the best optimized rank and lower my cost, right? That is how we can create an operations research model and then fit in the players to it, right? You have two dimensions, and then you have a plot against all the dimensions. The model you have is y is equal to mx plus c, right? And then when you give a lot of points, you don't have an equation. Earlier, what we used to have is the y is equal to mx plus c. The equation is already given to you, and then you plug in what the value of x and c is in order to get y. But in this machine learning problem, you don't have either m, which is a slope, or c, which is a bias, which is an intersection. You don't have both. You have only these dotted lines, these data points, right? And you have to do a fitting. That's called curve fitting, right? Curve fitting is a very, when you want to fit the curve, how do you fit the curve? So you do a hypothesis. You take 2 points, for example, point 1 and point 2. And then given point 1 and point 2, you will be able to arrive at, the equation for the line, right? Which is a mathematical concept, right? The model we have chosen to do here is a linear model. And then, we got the equation initially, and then next point comes in. Okay. So when the next point comes in, the slope and intersection, both of them change. That means if you want to fit those three curves, three data points, the tilt the tilt has to change. That means there has to be a way of measuring the error, right? So this y is equal to mx plus c is a mathematical equation. Y is equal to beta plus beta 1 x plus an error is a machine learning equation. Okay. So these intercept and coefficients and error function, this error function keeps changing as the new data comes in. Okay. And there is a way of measuring error equation. Here we call it MSME. That is a square of the errors, least squares methods, we call it. So that is the error function that we use it's a polynomial function. Here it is a quadratic square root function, but generally it is a polynomial, right? Any error function is a polynomial. In order to solve a polynomial, what techniques do you use? We use something called calculus, right? Maxima, minima for an equation, you have a function, and then how do you find it? It's an equation. So we are converting our conceptual human idea into something very, very substantial by using multiple models, representations, and various branches of mathematics. You see all these fitting together now. All of them are very important. And then when you see this X here, all observed values of independent variables, what is it? It is nothing but a matrix. So in this machine learning representation that we are learning, we have an error function which we maximize using calculus. That is actual learning piece of the puzzle. X gives the inputs for the learning, right? And then this is the model we are using. What is learned equation? The learned equation will have the beta 0 and beta 1. That's all you have. That is basically y is equal to mx plus c. And you give an unknown function and it gives a value. That's it, right? Here, you will be able to predict any of the values that you are given. Now, let's jump in. Here, I have this representation of x and y, okay? In the Cartesian coordinates. How do I separate this? One versus the other. How do I write in any equation to separate this? Okay? Gosh, I need math to come into play, right? Okay, that is Cartesian products, right? Cartesian coordinate. I have to use, if I were to use a polar coordinate, right, which measures in radials and angles, right? Cartesian products are x and y coordinates. Polar coordinates is a circular coordinate. Why? We have to represent this data into this. That means we have to apply a polar coordinates in order to do this. And then you can separate them very easily, right? You just write a line here. That means you convert the input and then you plot it, and you don't have to plot it. You learn this equation, right? The inputted text will be converted and then applied. Let's go to another example, okay? You have a Cartesian product like this, and then I want you to separate green circles and rectangles. Right? Okay. Here we will use another technique like this. We will add another dimension and then apply the same transform, which we call a kernel, right? That means, for example, we use a quadratic function to x, then it becomes a three-dimensional parabola, and then you use a plane to separate those two, right? The inner ones will step up and the outer ones, all this, right? Basically, we are seeing this by adding another dimension and then seeing this in 3 dimensions, right? And then use a plane to cut it. Okay. So this is topological transformation that we use to input data, right? Then you can linearly separate them. So what did we think about? So all these tricks of the trade comes from mathematics. These are simple mathematical ideas, right? We are not going to a lot of different equations, how they are done. It is very insightful and critical for us to understand that all quantification, addition, subtraction, division, all this are done by arithmetic, right? That is the first step of thing. The structure, the relation between various equations or various variables are understood by algebra, right? The space is understood by studying geometry and trigonometry. The change of certain aspects, the process aspects, are measured by calculus. That's how we understand things. So all of them will come into play simultaneously. I will skip this, but I would like to understand from you one thing. I'll just give this problem and then, let you think about it and then stop there. For example, I have a survey data. The survey data captures brand availability. This is we have done it for one of our customers. We are measuring the customer satisfaction in a customer, for a retail customer. We have all this for a website, right? For example, you take it Amazon, right? Our customer is not as big as Amazon, but we have all these product information, ease of checkout, recommendations, stock availability, shipping options, all these parameters, and we have gotten the information for about 1,400 customers, and we have about 19 questions here, and the answers are given on a scale of 1 to 10. Okay. The question is, how do we cluster them together, right? Just think about it like this. I have a set of histograms and I want to pull all these histograms likewise. How do we do this? Okay, that was the question. And then this question, this is a real struggle for me. In 2016, this customer has asked this question of me. And I was, like Sarita said, hotshot data scientist who have failed multiple times trying to solve these problems. And I failed here too. Okay. I solved this problem in a very, very unsophisticated, naive way. And it did not fix the problem till ChatGPT has come into play. And I have given ChatGPT this problem to solve my problem in 2022, 23 rather. Right? That is the first question I have given for ChatGPT, right? And it solved it in a flash. You will not be able to solve it because, it took me 8 years to solve it and a lot of thinking to solve it. I couldn't solve it and I don't expect you to solve it in a second. It is a very, very tricky problem unless you have a solid understanding of how we do this magic trick. This is one single slide you will ever see in your machine learning journey. And it is absolutely critical for you to understand deep down each of these measures because these are critical. Okay. There are multiple use cases, and then we don't have to reinvent. This is the learning I had, right? We are all sitting on the shoulders of giants. Right? All we need to know is what is out there. Okay. In order for us to do that, we have to do one human quality put aside called ego, right? And I know it all. These are the two things that we need to keep it aside and keep searching for the answers. And people have already done that, right? So the answer for me has come from a specific measure called chi-square distance. Okay. It's called chi-square distance. Okay. I have used that method in order to come with the personas of people. Can you believe it? What we generally do is we use this measure, right? It is like, we have a hammer and we solve all the problems with the hammer. No, you can't do that. See, for example, if you have a blade, you cannot cut a tree with the blade, right? You need a, saw, even saw will not do it. You need a power saw to do it, right? To cut a tree. So you have to use different techniques that are in mathematics. These are all completely in mathematics. And the secret sauce of the entire machine learning that is why I call it mathematics, right? Once you understand the tools of mathematics, your life becomes simple working with machine learning or understanding artificial intelligence. That's the takeaway I would like you to have. And then I will end my discussion at this point of time. I will answer any of your questions at this time.
Thank you. Thank you so much, Surya. This was very insightful. And then we are a little over the time, and I see people are getting off. But there is one question, maybe if you could help clarifying or answering for one of our participants from Pawan. His question is how AI can help pharma space work efficiently. Thank you so much, Pawan, for your question. I'm not sure if you're still there. I know we are running a little late, but maybe we'll take another couple of minutes and we'll wrap it up.
That's quite a loaded question. Yeah. But I would like Pawan to just do a quick search, okay, on the internet called AlphaFold. It is basically pharmaceuticals. When we say pharmaceuticals, what they do is they detect the target and then find a protein that can bind with that target. Right. So that is a combination of various chemicals that will have to bind specific disease. Right. So, I would like Pawan to look at AlphaFold. And there are, the drug discovery is a, very, very hot area where, you have to find out the possible candidates, and then you come to model it, synthesize it, run it through various trials, animal trials, clinical trials, on the human trials, etc., gather the data, and then finally go for FDA approvals and all that. It used to take 10 years, right? 10 to 15 years for a drug to come to market. But now with AlphaFold, it takes all the grunt work, all our creativity, all of those things into consideration, and then things have become a lot more simpler.
Thank you
Sure.
so much. This was very, very insightful, and you have really made it very impact. And I really appreciate all the audiences there. Thank you so much. We will be back again with another interesting topic next week, Friday. I'll see you all there again.